will carry on with the next section of transformer, and that is called the efficiency of the transformer. Now when we talk about efficiency, if you recall, efficiency in electrical engineering is always about efficiency. This is the symbol for efficiency. It's always about output divided by input times 100%. Yes or no? So output is equal to, okay, if I still leave it as output, then input is therefore output divided by input. Yeah, correct. Yes. Can I say that input is equal to output plus the losses? Right? Output plus losses, that's input, isn't it? Right? Because how do you get output? Output is because you use input minus losses. Okay. So now that brings us to our question is, what are the different losses in a transformer? Now, transformer has two types of losses. Okay, one is called the iron loss. This is a symbol for iron loss, and the other one is called the copper loss. Right? So there are two types of losses in transformer that they are significant enough for us to calculate, and they are the iron loss and copper loss. Okay, so let us bring us back to our diagram here, our parameters diagram. Still remember the English word? Core loss resistant, magnetizing reactance on the low voltage side. I put it here because for my convenience. If I put it there, then I'll call it RCHV and XMHV. Remember that? And this is the equivalent winding resistance at the high voltage side, and the equivalent leakage reactance at the high voltage side. Now, when we talk about power here, we always talk about real power. So the two types of losses, one is called the core loss, alright, which is also called the iron loss. And it's the loss in RCLV. Remember English word? Core loss resistant. And you do recall, this core loss is actually comes from this iron core. These two parameters are from the iron core. Okay, so when the power loss here, we call it core loss power, or we call it the iron loss power. The two names are interchangeable. Now, if you still recall, this is a parallel circuit. What's the best formula to calculate this power? Is V squared on R. The formula, the best is V squared on R, right? If I say it's RCLV, then which V do you use? VLV, correct. Right? If I were to move these to the high voltage side, then that becomes RCHV. Then which V do I use? Of course I use VHV. Correct? The answer will be the same. And that's the way you calculate the iron loss or the core loss. And it happens in the parallel circuit. Always remember it's parallel circuit. Then the other loss is the winding resistance. And winding resistance is made up of copper wire. And that is why it is called copper loss. Okay, copper loss happens in REHV. Alright? And because it's a series circuit, the best formula is I square R. So if I use REHV, then the I that I should use should be IHV. If I were to use RELV, then the I that I should use ILV. The answer will be the same. Alright, still remember how to calculate the I? Using S equal to V times I formula? Yes, so this is called a copper loss. Okay, let's pause for a while. In a transformer, how many types of losses that we want to calculate? Two. What are they? Core loss power and the copper loss. Which formula is best to find the core loss? V square R. Which formula is best to find the copper loss? I square R. Yeah? Now this V, because it's low voltage, so it's VLV. Yeah? And which I is this? IHV, because this is my high voltage side. So let's come back to our efficiency formula. Efficiency is equal to output divided by input. That's equal to output divided by output plus losses. Right? And we say that there are two types of losses, iron loss and copper loss. Now, what is output power, true power. Still remember ECAM? ECAM say P equal to S cosine theta, right? S cosine theta. So our output power will now be S cosine theta. S cosine theta. And you do recall that in transformer, we need not use up to 100%. If the question say I only use 60%, then you say fraction of full load. Remember, x 0.6 times 10 kVA times cosine theta. So that's the output power, right? So output power is xs cosine theta plus the two losses, iron loss and copper loss. Okay, and you still remember how to calculate iron loss? That is your V square R formula. Which formula to find copper loss? I square R. Yeah. If I say this RCLV, BLV. If I say I square R, here is REHV, IHV. Right? So that is efficiency. Efficiency of the transformer. This formula is provided in the exam. It's provided in the exam. But you must understand what it means. What does this mean? Fraction of full load. This is the apparent power. This is the power factor. Yeah? Iron loss, the power that happens in the parallel circuit, copper loss, the loss happens in a series circuit. Alright? Now let's continue a little bit more on the efficiency. Alright, so we understand that the efficiency formula is equal to output divided by input times 100%. Right? And that is equal to xs cosine theta divided by xs cosine theta plus iron loss plus copper loss times 100%. Okay? And still recall iron loss, the best formula is V squared on R. So if you use RCLV, there's VLV. Right? If you use RCHV, VHV. Right? And copper loss, the best formula is I square R. If you use REHV, IHV. If you use RELV, then it's ILV. Right? Now, then it comes to, if the question asks you, find the rated iron loss. Rated iron loss means the maximum. Then of course you use V squared on R still. Yeah, but which V? Of course the maximum voltage, the maximum voltage. Right? And the rated copper loss, you use I square R. And if you are using REHV, then you use IHV, but it must be the maximum. Must be the maximum. Okay? Alright, efficiency then continue with a new knowledge which is called the condition for maximum efficiency. Condition for maximum efficiency. If you want your transformer to work at maximum efficiency, you must satisfy this condition. And this is not given in the exam, so you must remember this formula, yeah? Which is equal to square root of iron loss divided by copper full load. Copper full load means the maximum copper loss, rated copper loss. So, maximum efficiency, let's say you have the value, alright, you calculate the answer here is 0.75. Right? Then you find the efficiency. Efficiency is equal to xs cosine theta divided by xs cosine theta plus iron loss plus copper loss times 100%. Right? So let's say you calculate out the value is 0.75, you substitute the 0.75 into here. Yeah? That everything is still the same. Everything is still the same. Of course, you must calculate your iron loss and your copper loss accordingly. Right? What do we mean by calculate them accordingly? Iron loss, usually no change. Because in a transformer, when we operate on a fraction of the load, we don't change the voltage. Right? Usually it's the current change. Because the load change, the amount of current drawn is different. Right? So iron loss, usually you take it as constant. Right? Unless we change the voltage. But copper loss would usually change. Because copper loss is I square R, remember I said it's I square R. So if I draw different amount of current due to the different fraction of the load, my current change accordingly. So you have to recalculate. Now in your notes, there is actually a formula, say copper loss is equal to x squared copper full load. Alright? I won't advise you to memorize this, even it's not provided in the exam, because I find that you can use the basic formula to calculate it. You know, go and find using S equal to V times I to find the new I, and then I square R, you find the copper loss, instead of adding on to remember one more formula. Okay? Alright, so that is all about the efficiency. So now maybe I practice you with the questions on efficiency to wrap up this video revision on efficiency. Right? So example, there's a 10 kVA transformer, and this is 220 600 volt transformer, and you're told that RCLB is equal to 147 ohm and REHV is equal to 1.5 ohm. Right? And it's operate at a fraction of 0.85 fraction of full load, and the power factor is equal to 0.92 lagging. Right? And you're asked to find the efficiency of this transformer. Okay? Alright, so what do? You say efficiency is equal to XS cosine theta divided by XS cosine theta plus iron loss plus copper loss multiply 100%. The fraction 0.85, my apparent power is 10 kVA, cosine theta is 0.85. No, my power factor is 0.92. Okay? And divided by 0.85 times 10K times 0.92. Right? Plus, how do I calculate the iron loss? Can you still remember it's a parallel circuit, so you use V square on R. Yeah? V square on R. Okay, so if you use V square on R, copper loss you will use I square R. Yeah? Okay, let's bring it out. So it's V square on R. Which R? Which R? RCLV. Which V? VLV. Right? So the VLV is 220 square and the RCLV is 147. Got it? Copper loss. You use I square R. Which R? REHV. Which I? IHV. Right? Okay, REHV no issue, you know it's 1.5. How do you calculate I? You calculate I using the formula S equal to V times I. S equal to V times I, right? So I equal to S divided by V. So it's S divided by V. Which V? VHV. VHV. Right? So what is the value of the S? The value of the S is 10 kVA. Right? The value of the V is 600. But be careful. Am I using full load? No, I'm not using full load. I'm using partial of the load. So my apparent power, is it 10 kVA or 0.85 times 10 kVA? It should be 0.85 times 10 kVA. Because the question here is that I'm not operating on full load. I'm operating on partial of the load. Right? So 0.85 times 10K, that's my load. That's not 10 kVA but 8.5 kVA, and the voltage is 600 volt. So with that I got my copper loss and get all my values and my efficiencies out. Alright? Yeah, try your tutorial questions or even the revision paper. Then you should make sense of what I'm talking about here. Okay? And that is efficiency of the transformer.